professor at IJ Institute of Engineering and Technology. Today we will discuss few more topics of Fourier series. So let's begin with the first topic, that is Fourier series of an even function fx in the interval minus L to L. So first thing, remember here we are taking an even function and in the interval minus L to L. Okay, so f of x will be a0 by 2 plus summation n from 1 to infinite an cos n pi x upon L. So whenever we have interval minus L to L, you have to write in this form, that is n pi x upon L. Okay, now the value of a0 will be 2 upon L integration 0 to L f of x dx, and the formula for an will be 2 upon L integration 0 to L fx cos n pi x upon L dx. Okay, so and bn will be equal to 0. So whenever we have even function and the interval is minus L to L, a symmetric interval, right? So in that a0 will be this, an will be this, and the value of bn will be 0. Next, the Fourier series of an odd function in the interval minus L to L. Okay, so here the fx formula will be summation n from 1 to infinite bn sin n pi x upon L, and the bn will be 2 upon L integration 0 to L fx sin n pi x upon L dx, and a0 and an will be equal to 0. So whenever we have an odd function and we have the interval that is minus L to L, we will use this formula, right? Here a0 and an is 0 and bn is 2 upon L integration 0 to L fx sin n pi x upon L dx. So now let's begin with the example. The first example here we have is find the Fourier series of function fx is equal to x square in the interval minus 2 to 2. Right? So here the interval is in the form of minus L to L. Right? And the function fx is given x square. So firstly we will check whether the function is even or odd. So for that what we have to do? F of minus x. Right? So f of minus x is what? Minus x whole square, right? So this is equal to x square and this is equals to function fx. Therefore we can say that the function fx is an even function. Okay, now we have to find L. Okay, so now here the interval is given minus 2 to 2, right? So just compare this with minus L to L. So you can see that the value of L is what? So here we have L is equals to 2. Now the function is even function. So what we have to find? We have to find a0 and an, bn will be equal to 0. Okay, so the formula for a0 is 2 upon L integration 0 to L f of x dx, right? Substitute the value of L, that is 2. So here we have 2 upon 2 integration 0 to 2. fx is what? X square dx. Okay, so just integrate it. This 2 will get cancelled. So what we have as an integration here? We have x cubed by 3 and the limit is what? 0 to 2, right? So just substitute the limit. So here you will get answer 8 by 3 minus 0. So final answer for a0 is what? 8 by 3, right? Now let's find an. So the formula for an is what? 2 upon L integration 0 to L f of x cos n pi x upon L, right? Now we will substitute the value of L and function fx. So L is 2 and fx is what? X square. So here we have x square cos n pi x upon 2. Okay, now to solve this integration we have to apply this UV rule. So integration u dot v dx is equal to what? uv1 minus u dash v2 plus u double dash v3 and so on, right? So here firstly this 2 will get cancelled, okay, and just integrate it. So here our u is what? X square and v is what? Cos n pi x upon 2. Okay, so firstly u is kept as it is, so x square as it is. Integration of cos n pi x upon 2 is what? Sin n pi x upon 2 upon n pi by 2. Okay, minus, now we have to find the derivative of this x square, that is 2x, so into 2x. Now integrate this, so on integration you will get minus cos n pi x upon 2 whole divided by n square pi square upon 4. We have one n pi by 2 and another n pi by 2, so it will become n square pi square by 4. Okay, so lastly plus. Now again we have to take derivative of 2x, so that is 2, and the integration of cos n pi x upon 2, so it is minus as it is, so here we have sin n pi x upon 2 upon here we have n cube pi cube upon 8. Okay, and the limit is 0 to 2. Firstly we have to apply the upper limit, right? So here first apply the upper limit in the sine function. So here we have 2, so 2 will get cancelled and what remains is sin n pi. Now we know the value of sin n pi, so sin n pi is equals to 0, and cos n pi is what? Minus 1 raised to n. Okay, and again here we have sin n pi, that is 0. Now when we will substitute the lower limit 0, here you will have sin 0 as 0. Here you will have, here in place of x if you will substitute 0, so this term will also be 0, and here also this term will be 0. So only we have one term here when we substitute x is equal to 2, right? So on substitute here x is equal to 2, so here we have 4, this minus minus will become plus, and here we have cos n pi upon n square pi square upon 4. Okay, so further simplified, so you will get an as 16 minus 1 raised to n upon n square pi square. Okay, now we have to substitute the value of an and a0 in the fx formula. So fx is equal to what? a0 by 2 plus summation n from 1 to infinite an cos n pi x upon l. Okay, so a0 is 8 by 3, so here we have 4 by 3 plus take 16 upon pi square out, so here we have summation and from 1 to infinite an is what? Minus 1 raised to n upon n square pi square taken common, 16 taken common, so here we have n square and cos n pi x upon l is what? 2, so here we have 2. Right, so this is the Fourier series of a function x square in the interval minus 2 to 2. Now let's see one more example. So the example is find the Fourier series of function fx is equal to x minus x cube in the interval minus 1 to 1. Okay, so here again we have interval in the form of minus l to l. So compare with this, so you will get the value of l as 1 and the function fx is equal to x minus x cube. So first we will check whether this function is odd or even. So for that write down f of minus x. So f of minus x is what? Minus x plus x cube. Take minus common. So here you have x minus x cube, that is function fx. So this is equal to minus of fx. So here we have f of minus x is equal to minus fx. So the function fx is an odd function. So whenever we have odd function, a0 and an will be equal to 0. What we need to find is bn. Okay, so firstly we will find L. Now period P is equal to 2L, that is equal to 2. So we have L is equals to 1. Right, now the Fourier series fx formula is summation n from 1 to infinite bn sin n pi x upon L. The value of L is what? 1. So just substitute the value of 1. So here you will get fx is equal to summation n from 1 to infinite bn sin n pi x. Now we need to find bn. So the formula for bn is 2 upon L integration 0 to L fx sin n pi x upon L dx. Okay, substitute the value of L. L is 1, so here we have 2 and the function fx is what? X minus x cube. Here we have sine n pi x upon 1, so only sine n pi x. Okay, now to solve this integration, again we have to apply this rule, u into v dx, that is equal to u v1 minus u dash v2 plus u double dash v3 and so on. Okay, so firstly we'll take this term as a u and this we will take as v, and you have to apply this uv rule formula. So u is kept as it is. Here v1, so integration of sine n pi x, that is minus cos n pi x upon n pi, minus u dash, so derivative of this term, and then integration of this term. So here you will get answer. Okay, again follow the same procedure, right, and simplify and substitute the limit. So you will get answer here as 2 into minus 6 cos n pi upon n cube pi cube. Here you can see when you will substitute 1 here, so here 1 minus 1, so it will become 0. Here on substituting 1 we have sin n pi and that is 0. We know the value of sin n pi 0, so this term is 0. Substitute 1 here, so here you will get minus 6 cos n pi upon n cube pi cube. This I have written here. Here sin n pi, it is again 0, right? Now substitute lower limit. So on substituting lower limit, here we have 0. So this term is gone, sin 0 is 0, so this term is gone. Again here we have x. So when you substitute 0 here, so this term is also gone, and here sin 0 is 0. So all the terms are 0 for lower limit. So only we have this term. And we know the value of cos n pi, that is minus 1 raised to n, right? So this is the answer for Bn. Now we will substitute the answer of Bn in the formula fx is equal to summation Bn from 1 to infinite Bn sin n pi x. Okay, minus 12 and pi cube was constant, so taken out of the summation, and this is the answer for fx. So if you want to expand it, you can expand it like this. The function fx is x minus x cube, which is written here, and on substituting n is equals to 1, so here you will get minus sin n pi x. So minus taken common, so minus minus will become plus. So here we have sin pi x. Then for n is equal to 2, so here we have 1 upon 2 cube, right? Again, as minus is taken common, so here we have minus n. Next, here we have plus n. So in this way we have just expanded to get the Fourier series of a function fx. Okay, so in all what we had discussed today, the interval we had was minus L to L. Okay, so firstly we have to check whether the function fx is even or this function fx is odd function. Okay, so if the function is even, we have to find a0, and the formula to find a0 is what? 2 upon L integration 0 to L f of x dx. Okay, and the formula to find an is what? 2 upon L integration 0 to L fx cos n pi x upon L dx, right? And the formula for fx will be what? a0 by 2 plus summation n from 1 to infinite an cos n pi x upon L, right? And when we have the function fx as an odd function, a0 and an will become 0. What we have to find is only bn, and the formula for bn is 2 upon L integration 0 to L fx sin n pi x upon L, right? And the fx formula will be summation n from 1 to infinite. Here we have bn sin n pi x upon L. Okay, so in this way we will solve the example when we have the interval minus L to L. Thank you for watching.